So the first one is worth 4 points. It's not worth 4 points because there are 4 answers. It's worth 4 points based on what I want to see. So the first thing I want to talk about is the vertex. So it's always the opposite, and then that's the straight shooter. So 6, -8. That's the kind of work I want to see. So you know that's not the right answer.
Please stand for the
To get the y-intercept, you take 0 and you plug it in for x. So I'm going to come over here, and I'm going to go 4/3, 0 minus 6, 8. Based on PEMDAS, 0 minus 6 is -6 squared, which is 36. 36 times 4/3, 3 goes into 36 12 times, and 4 times 12 is 48. Don't forget the -8. So it's 0.40. That's a possible answer. It's saying it opens up. Well, that's positive. So yes, it does. There are 2 x-intercepts. Well, I don't know how many x-intercepts are. So what I'm going to have to do is actually find them. So when I find the x-intercepts, I make the y equals 0. So I'm going to take 0, 4/3, x minus 6 squared minus 8. First thing I'm going to do is add 8. Next thing I'm going to do is get rid of the fraction. So I'm going to multiply by 3. Since this is being multiplied, then I can just do that whole thing. So that goes away. And I'm left with 24 equals x minus 6 squared. Oops, 4. Now I'm going to divide by 4. Some of you will do this all in one step, and that's fine. Now I square root. Square root equals plus or minus. I can't take the square root of 6, so I leave it. Add 6 to both sides. So x equals 6 plus or minus square root of 6. So I do have 2. I have 6 plus square root of 6, and I have 6 minus square root of 6. So yes, there are 2, which means it's not that there are 0. The end behavior. Well, the end behavior is based on the fact that it's going up. So since it's going up, the end behavior is positive infinity. So it's not negative infinity. So the only thing left is to change this from vertex form to standard form. Okay? And now what you can do is you just pick up your calculator and you can set them equal to each other. So go to calculate, and I'm going to type in control divide. Let me make this a little bit lighter so you can actually see. So I'm going to go, I can go here and get the divide, or I can go control divide. And I'm going to take 4/3, and I'm going to get out of there, parenthesis, x minus 6, get out of the parentheses, squared minus 8, and I'm going to set it equal to, so that's my standard form, or my vertex form. I'm going to set it equal to my standard form. Control divide, 4/3, x squared minus 8x plus 8. Oops, what's the syntax error? Oh, it might not. Oops, okay. Let's try this again. Press enter. Oh, I didn't store a value for x. Darn it. So remember, store a value for x. Take 2. To store it, see where it says yellow STO? So go yellow var for x. Now that I stored it, now you can do this. Go up, 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 up. And now that it's hovered over blue, press enter and do it again. It says false. So that means that it's not true. And then you can just write like that, and then just don't circle it because you used your calculator. Okay? Let's make sure I did that right. 4/3 x squared minus 8x plus 8. Okay? So that's that problem. Let's go to the next one. So this one is worth a whole lot of points. So I'm going to start here. This is down, so I'll just circle down. As soon as I know it's down, I know the end behavior. As x approaches negative infinity, f of x approaches negative infinity because it's going down. As x approaches positive infinity, f of x approaches negative infinity. Okay? All right, so that's done. All right, so I know if it's going down, it's going to look like this. That means it's a max, and we have to figure out what the vertex is. So we can't find what this actually is until we get the vertex. So we can't get the axis of symmetry until we get the x value of the vertex. So if you remember, there's a formula, negative b over 2a. And I'm going to write down my a. My a is negative 1. My b is negative 4. And my c is negative 1. Let me zoom that in a little bit. So I'm going to go negative of negative 4 over 2 times negative 1. Negative of negative turns positive. 4 over negative 2 is negative 2. I just got the x value of the vertex. Let me zoom that out now. So now it's x equals negative 2, and there's my negative 2 right there. Okay? Now to get the y value of the vertex, I'm going to take this negative 2, and I'm going to plug it in for x. You want to be careful because with the negative, there's an imaginary negative 1 times negative 2 squared minus 4 times negative 2 minus 1. Take care of the exponent first, then multiply by negative 1. So I get negative 4. A negative times a negative is a positive. Negative 4 plus 8 is 4 minus 1 is 3. Boom, boom. Okay? Let's do the x-intercepts first. So to get the So to get the x-intercepts, you've got to set the y equal to 0. And I'm going to try to factor, but I know that I can't factor. So since I can't factor, I have two options. I can complete this square, or I can just do the quadratic formula. I don't know about you, but quadratic formula seems a little bit easier to me. So I'm going to take up a lot of space, and I'm going to do that. If this is something where you want to take up a lot of space, I suggest you get a piece of scratch paper like I'm going to do, and you do the problem. So negative x squared minus 4x plus 1. I wrote that down. I'm going to show all my little baby steps. Identify my A. Identify my B. Identify my C. Put the formula over here. Okay? And now that I have those, I'm going to do this problem. So I start with negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now, remember I said I think this is the most difficult, so take care of that first. So negative 4 squared is 16. And then multiply all of this. And when you multiply all of it, don't look at the negatives, just look at the numbers. 4 times 1 is 4, times 1 is 4. And a negative make a positive, and you're left with that. I have the square root of 12. Now it's a lot easier, plus or minus. A negative of a negative is positive over negative 2. Okay, a couple issues. First issue is this negative should be on the top. So it's now negative 4 plus or minus 12 over 2. Then I have to make sure I'm treeing 12, 2, 6, 2, 3. Circle the doubles. Negative 4 plus or minus 2 rad 3 over 2. Now, since all of these divide by 2, your answer is really negative 2 plus or minus rad 3. So you have two x-intercepts, and that's what they are. So one of them is negative 2 plus rad 3, comma 0. And the other one's negative 2 minus rad 3, comma 0. Okay? So I'm going to write that down. Negative 2 plus rad 3, comma 0. Negative 2 minus rad 3, comma 0. So I did do quadratic formula. I actually want to show you how to complete the square, because maybe in this case, completing the square would have been easier. So if I'm going to show you how to complete this square, and if you don't care, you'll just fast forward. Remember, in order to complete the square, this has to be positive and there can't be a number in front. So divide everything by negative 1. And then move the 1 over. And now complete the square. So I'll do that down here. X squared, split it. So that's 4. X plus 2. X plus 2. So that magical 4 right here goes right there, plus 4, plus 4. This side is a 3. Interesting, huh? And then this is x plus 2 squared. Square root, square root. X plus 2 equals plus or minus rad 3 minus 2 minus 2, x equals negative 2 plus or minus rad 3. If you notice, it's the same thing as the quadratic formula. I don't care which one you do, but pick one of them. And as a side note, as I'm showing both of these, you're going to have a bonus question that's going to say, and I can't tell you what it's going to be, but solve for x in 3 different ways. So here would be, if this was the example for the bonus, this would be 2 ways, and then you'd have to pick a 3rd way. Okay? All right, the long story of that one means I just got the x-intercepts. Now to get the y-intercepts, I plug in 0. Well, if you plug in 0, gone. If you plug in 0, gone. So boom, the y-intercept is just the y value. Okay, the intervals. The intervals are based all on the vertex, okay? But remember, it's negative infinity, and this is positive infinity, negative infinity, and the vertex is negative 2, 3. So if you look, the interval is negative infinity to negative 2, increasing, and then it's from negative 2 to positive 2, decreasing. So that means it's from, where did I get lost? Negative 2 to positive infinity, decreasing. Okay? We know the domain of every one was all real numbers. Negative infinity, positive infinity. And the range isn't all real numbers because it's a u. It's only going down, so y is less than or equal to. It's all based on the y value of the vertex, so that 3 goes right there. And then I have to put it in interval notation, which is negative infinity, comma, 3, bracket. This was a lot of work, which is why it's worth 18 points.